Hello everyone, welcome to my Terraform course. In this video, I want to show you the full learning roadmap of this course. This course is designed to take you from zero to professional and to real production systems. Just follow step by step. Lesson 1. Lesson 0. Infrastructure as Code Fundamentals. We start with Lesson 0. This lesson is not about writing code. It is about how to think. You will learn what is infrastructure as code, why Terraform exists, why manual infrastructure is dangerous. If you understand this lesson, Terraform will make you more sense later. Lesson 1. Terraform basics and setup. In the lesson, we start with the basics. You will learn how to install Terraform, how Terraform works, basic commands like init, plan, and apply. This lesson helps you feel comfortable with Terraform tools. Lesson 2. Terraform concept. This is one of the most important lessons. You learn providers, resources, data sources, dependency graph. This concept are the foundation of Terraform. If you skip this lesson, Terraform will feel confusing. Lesson 3. Terraform state and state management. In this lesson, we talk about Terraform state. You will learn what is Terraform on TF state, why state is important, local state, and remote states. State is powerful but also dangerous if you don't understand yet. Lesson 4. Variables, outputs, and reusability. In the lesson, you learn how to write clean and reusable code. You will learn input variables, output values, how to reuse Terraform code. This lesson helps you work in teams. Lesson 5. Terraform functions. In this lesson, we go deeper. You will learn Terraform built-in functions, how to process strings and lists, how to write flexible configurations. This lesson helps you write smart Terraform codes. Lesson 6. Modules. This is the heart of Terraform. You will learn what Terraform modules are, how to design reusable modules, how real companies use modules. Without modules, Terraform cannot scale. Lesson 7. Multi-environment and workspaces. In this lesson, we talk about real environments. You will learn that staging and production, Terraform workspaces, environment strategies. This is very important for real projects. Lesson 8. Security and secret management. Security is very important. In the lesson, you will learn how to handle secret safety, how to avoid hard coding passwords, basic security best practice. This helps protect your system. Lesson 9. CI/CD with Terraform. In this lesson, we connect Terraform with CI/CD. You will learn how Terraform works in pipeline, automation with GitHub Actions or GitLab CI, safe deployment strategies. This is how Terraform is used in real companies. Lesson 10. Testing and quality control. In the lesson, we focus on quality. You learn how to test Terraform code, how to avoid breaking production, validation and test. This lesson helps you sleep better at night. Lesson 11. Advanced Terraform patterns. In the lesson, we go advanced. You will learn advanced design pattern, how to handle complex systems through architecture examples. This lesson is for experienced learners. And 12 lesson. Terraform anti-pattern and debugging. In the lesson, you will learn what not to do. You will learn common Terraform mistakes, best practice, how to debug problems. This lesson helps you avoid pain. Lesson. Bad practice and creative. In the lesson, we talk about your career. You will learn Terraform best practice, how to work like a professional, creative for DevOps and Cloud. This lesson helps you grow long term. For lesson 14, custom projects. Finally, this lesson is a hands-on project. You will build a real system, use everything you learn, work like a real DevOps engineer. This is where everything comes together. Finally, this course is step by step, beginner friendly, practical and real. If you follow all lessons, you will not only know Terraform, you will think like a Terraform engineer. Thank you for watching. See you in the next video. Before we talk about Terraform commands, before we write any code, I want to stop for a moment. This lesson is very special. This lesson is not about teaching Terraform. It is about teaching how to think. Many people learn Terraform syntax very fast, but they still fail in real projects. Why? Because they do not understand why Terraform exists. So today, we will talk about mindset, not tools. Let's talk with one simple question. Why do we need Terraform and infrastructure as code? This question is very important. If you understand the answer, Terraform is very easy and logical. If you do not understand it, Terraform will feel confusing and painful. So let's go step by step. The problem, the solution, and the conclusion. Manual infrastructure. First, let's talk about manual infrastructure. This is the traditional way. Manual infrastructure means you open AWS console or Azure Portal or Google Cloud UI. Then you click button, few input fields, press create. Everything looks simple. Many teams start like this. Manual infrastructure has these characteristics. Resources are created by clicking. Knowledge is stored in people's heads. Very dependent on one or two engineers. There is often no documentation, no history, no clear ownership. In the work situation, let me ask you, have you ever heard these questions? Who created this server? Why is the production different from staging? Can we rebuild this system if it breaks? Very often, the answer is, I don't know, August. The person who knows already left the company. Many infrastructure creates many problems. You cannot reproduce the same environment. There is no version control. You cannot see who changed what. Auditing is very difficult. This creates something called snowflake servers. Each server is unique, each server is difficult, and you cannot recreate it. This is very dangerous in production system. Manual infrastructure works at the beginning, but it fails when system grows. Infrastructure as code. Now let's talk about the situation. Infrastructure as code means we manage infrastructure using code, not using click. Instead of clicking in the cloud console, we write files, we declare infrastructure, we store files in Git. Infrastructure becomes visible and clear. What does it look like? Infrastructure is written in text files. Files can be reviewed. Files can be changed. Files can be run back. This is exactly how we work with software. And what problem does it solve? It gives us version control, change history, code review, automation, and reproducibility. Now infrastructure is no longer magic, it is code the everyone can read. Simple comparison. If your infrastructure is not in Git, you do not truly control it. Pain point in real DevOps teams. Now let's look at real problems that DevOps teams face every day. Here are every common problems. Development, staging, and production are different. No one knows who changed infrastructures. There is no rollback when something breaks. New engineers need weeks to understand systems. Scaling is slow and risky. These problems are very expensive. They cost time, money, and sometimes customer trust. The root cause. Why does this problem happen? Infrastructure is not managed like software. People treat infrastructure as something manual, something special, something only senior people talk. This is wrong. With infrastructure as code, it fits. Infrastructure becomes code. Code follow software rule. That means version control, code review, automation, CI/CD pipeline. Infrastructure as code turn infrastructure into a first-class citizen of software development life cycle. Imperative and declarative thinking. This part is very important for understanding Terraform. Imperative thinking. It means, how do I do it? You tell the system step by step. For example, first create a VPC, then create subnets, then attach row tables, then create an EC2 instance. This approach has problems. Order is very important. Changes are risky, easy to break existing system. This is how scripts usually work. Declarative thinking. Terraform style. It means, what do I want? You describe the final result. For example, I want one VPC. I want two subnet. I want one EC2 instance. Terraform will check the current state, compare it with the design state, decide what to create, change, or delete. You do not control how, you only describe what. Terraform does not need instructions, it only needs your design state. Terraform is the DevOps ecosystem. Terraform does not work alone, it is a part of a bigger system. Terraform is used for provisioning infrastructure, that means networks, servers, database, load balancers. Terraform creates the foundation, all the tools and all the roles. Let's look at all the tools. Ansible, configure servers. Docker, package applications. Kubernetes, run containers. CI/CD, automation and delivery. Important point. Terraform usually runs before these tools. Simple way to remember. Terraform builds the house. Ansible sets up the room. Docker packs the furniture. Kubernetes manages everything inside. Terraform is foundation of modern infrastructure. When to use and not use Terraform. Terraform is powerful, but it is not for everything. Use Terraform when you provision cloud infrastructure. You manage many environments. Team needs audit and review. Infrastructure changes often. Automation is important. Terraform is perfect for AWS, Azure, Google Cloud Platform. Do not use Terraform when you only configure software inside servers. You run simple runtime script. You need real-time description. You need complete runtime logic. Terraform does not replace Ansible shell scripts. It works with them, not instead of them. Real-world use case. Terraform is used everywhere today. Terraform is used for AWS, Azure, Google Cloud Platform infrastructure, multi-account and multi-region system, CI/CD foundation, microservice platforms. Real-world example: startup use Terraform for the whole cloud. Enterprise use Terraform for governance. DevOps team use Terraform for self-service infrastructure. Terraform helps teams move faster, make fewer mistakes, work together better. Conclusion. Let's finish this lesson. Terraform is not just a tool, it is a way of thinking. Infrastructure is code, code must be versioned, change must be reviewed, system must be reproducible. If you remember only one thing from this video, remember this: before learning Terraform syntax, you must understand Terraform mindset. Welcome to lesson 1, Terraform basics and setup. This is a very important lesson. If you understand this lesson well, everything later will become much easier. In this lesson, we will not jump into complete code. Instead, we will focus on how Terraform works, how you should think when using Terraform, the standard workflow used in real companies, So let's take your time and let's begin. By the end of this lesson, you will be able to understand how Terraform works internally, install Terraform the correct way, understand the standard Terraform workflow, understand your work project structure, run your first Terraform project. If you can do these 5 things, you already have a solid foundation. Before we learn commands or files, we must answer one key question: how does Terraform works? Or in simple words, how does Terraform turn your intention into real cloud resources? For example, you want an EC2 instance, you want an S3 bucket, you want a database. Terraform does not guess. Terraform only does exactly what you describe. So Terraform is not magic. It is a translator between your ideas and cloud API. Keep this idea in mind. Terraform CLI. What is Terraform from a user perspective? From your point of view, Terraform is a command line tool. That means you do not click button. You do not use a web UI. You type commands in the terminal. For example, Terraform init, Terraform plan, Terraform apply, and Terraform destroy. These 4 commands are the heart of Terraform. If you understand the commands well, you understand Terraform. The role of Terraform CLI. So what does the Terraform CLI actually do? Terraform CLI is responsible for reading your .tf files, then taking to cloud provider like AWS or Azure, then comparing 2 things: besides state what you want and actual state what already exists. Then Terraform decide what to create, what to update, what to delete. Terraform is always about state comparison. The idea will appear again and again in later lesson. Installing Terraform. Now let's talk about installation. There are 2 common ways to use Terraform. Option 1, local installation. This is the more common option. Steps are simple. Go to HashiCorp website, download Terraform library, add it to your system path. Terraform support Mac OS, Linux, Windows. This option is great for learning, local experiment, daily DevOps work. If you are a beginner, this is the best choice. Option 2, using Terraform with Docker. You can also run Terraform inside Docker. This option is useful for CI/CD pipeline, build servers, teams that want consistent environment. Terraform workflow, very important. Now we arrive at the most important part of this lesson. Terraform has one standard workflow, always, no exception. First, init, then plan, then apply and destroy. You should memorize this. Let's go through each step slowly. Terraform init. This is always the first command. What does it do? Initialize the project, download providers, create pawn Terraform's director. Terraform does nothing without init. You run Terraform init once per project or when provider change. Terraform plan. This is a safer command. Terraform will read your code, compare design state with actual state, show you what will happen. Important. No result is created. No result is deleted. Terraform answer this question. If I run apply, what will happen? In real company, plan is mandatory. Terraform apply. Now we move to action. Terraform apply will create a plan. As for confirmation, execute the trend. This is moment. Cloud API are gone. Real resources are created. This is a powerful command. Always review before confirming. Terraform destroy. This command does the opposite. It removes everything Terraform managed, used for lab, testing, cleaning up resources, saving money. Never run destroy in production unless you are 100% sure. Standard Terraform project structure. Let's look at a typical Terraform project. This structure is not random. It is widely used in startup, enterprise, production system. If you follow the structure, other engineers will understand your project immediately. Important Terraform file types. First, TF files. These are main configuration files written in ACL command files, main TF resources, variable TF input variables, output TF output variable. You can split files by purpose, not by Terraform rules. TF var. This lesson stores variable values. Why is this important? Because it helps separate code environment configuration. Example, that's TF var. Same code, different environments. On Terraform directory. This directory is auto-generated, managed by Terraform content provider libraries. Lesson cat never commits this folder to Git. Terraform provider. What is a provider? A provider is the bridge between Terraform and external system. Example, AWS, Azure, Google Cloud Platform, Kubernetes, GitHub. Terraform itself creates nothing. Terraform only sends API request. Provider is a Terraform driver. Without provider, Terraform cannot talk to the world. First, Terraform project. Now let's make this real. The goal is simple. Terraform can create real cloud resources. We keep it simple. Create an S3 bucket or create an EC2 instances. No complete logic. Focus only write the TF file, running the workflow, and seeing resources in AWS console. This is where learners usually say. In this lesson, we learn something much more important. Today's question is how the Terraform think. If you understand this lesson, you will stop making beginner mistake, and you will start thinking like a professional Terraform engineer. The biggest mistake beginner makes is this: letting Terraform runs line by line like a script, like this. Line number 1 runs first, line number 2 runs next, line number 3 runs after that. This is how script work. For example, Bash, Python, or Shell script. But Terraform is not a script. Terraform works in a very different way. Before it creates anything, Terraform always does 3 steps. Step number 1, read configuration. Team read on .tf files in the folder. Not one file, not one line. On files, on at once. Step number 2, build a dependency graph. Terraform analyze which resource depends on which, what must be created first, what can be created later, what can be created at the same time. The graph is called the dependency graph. Step number 3, execute the graph. Terraform then create, update, delete resource in the best position order and in parallel when possible. Important conclusion before update: the order of code does not matter. Dependencies decide everything. Please remember this. This idea is the heart of Terraform. Let's repeat the big picture one more time. Terraform always thinks like this: with own configuration, build dependency graph, execute the graph. So when you write Terraform code, you should not think like a programmer. You should think like an architect. Provider, the gateway to the outside world. What is a provider? A provider is a plugin. It tells Terraform which Terraform to connect to, which API to call, how to create, update, and delete resource. Example, provider AWS, talk to AWS API. Google, talk to Google Cloud. Kubernetes, talk to Kubernetes API server. Terraform itself does nothing without provider. How Terraform thinks about provider? Terraform thinks like this: before I create any resource, I must know how to talk to system. So provider as always load first. Important note: in one project, you can have one provider, multi-provider, multi-AWS account, multi-region. This is very important in your project. Resources. What is a resource? A resource represents a real object in infrastructure. For example, EC2 instance, S3 bucket, VPC, IAM role, Kubernetes deployment. How Terraform sees resource? Terraform sees each resource as one node in the dependency graph. Each resource has design state, what you write in code, real state, what exists in cloud. Terraform compare them and create a plan. Very important idea. Terraform does not care which file the resource is in, where is it writing in the file. Terraform only care about which resource dependent on which. Data source are used to read information from existing infrastructure without creating anything new. Example, get an existing VPC, fix the elastic AMI, read subnet or archive information. Correct mental model. Please remember this very clearly. Resource, create and manage. Data source, read only. Dependency rule, resource can depend on data source. Data source never depend on resource. This rule is very important for correct design. What are input valuable? Input valuable help you avoid hardcode values, reuse code, support multiple environment. Example, AWS Rugen instance style environment that staging product. How Terraform think about variable. Terraform think configuration is a template. Variables are input to that temp. Very important. Variable do not create resources, do not control execute order, do not create the dependencies. They only change values. Output value. What are output? Output allow Terraform to show value after apply, share data between lessons, share data between modules, pass value to CI/CD pipeline. Example, EC2 public IP, ARN, load balancer, GNS name. Correct mental model. Output is the final result of the graph. Output depends on results, not the other way around. Local value. What are local? Local value are temporary variables used for calculation, used for naming and comforting. How Terraform sees local. Terraform thinks locals are helper, nothing more. Locals do not create resources, are not output, and do not affect the graph unless used by resources. Dependency graph. This is the more important part of this module. This is the more important part of the lesson. Dependencies is what is the dependency graph? It is a graph that shows relationships between resources, data source, output. Terraform uses this graph to decide what comes first, what comes later, what can run in parallel. Comment set. Please remember this sentences. Terraform does not execute sequentially. It executes a dependency graph. How dependencies are created? Dependencies are created in two ways automatically when one resource references another, and manual using depend on. Meta argument. Meta argument are special key. They are not part of any provider, but they strongly affect the dependency graph. Dependency on. Used when templates cannot understand the dependencies. Example, IAM role must exist before policy attachment. Masters, Terraform do not know, so I must tell it clearly. Count. You to create multiple resources by number. Example, create 3 EC2 instances. Terraform thinks one resources with count equal 3, mean 3 nodes in the graph. For it, use when its resources has a clear identity. Work with map and sets. Correct my sets. Resources are named entity, not a list. Benefits more stable, safer for production. Strongly recommend. Final message what you must remember. Terraform is declarative, not imperative. You describe what you want, not how to do. Okay, remember this rule. If you remember only three things, remember this. Code order does not matter. Dependencies matter more than logic. The crap. This is everything. If you understand this lesson, you will write clear Terraform, debug faster, avoid dangerous mistakes, think like a real DevOps engineer. In this lesson, we talk about something very critical. Today's key question is how the Terraform remember infrastructure. This lesson is very important because most Terraform disasters happen because of state problem. Terraform does not look at the cloud and say, oh, I see what you create. No. Instead, Terraform remembers everything uses a special file. That file is called Terraform state. Terraform state is Terraform's memory. What is Terraform state? Terraform state is a data file, usually named Terraform.tf state. This is used to record what resources were created. Store real cloud ID like instance ID, ARNs, and name. Connect Terraform code to real infrastructure. What happens if there is no state? If Terraform has no state, it cannot know what already exists, what was created before. This can cause duplicate results, accidental deletion, or broken infrastructure. Without state, Terraform is blind. That is why state is foundation of Terraform. Local state and remote state. Now let's talk about where state is stored. Local state. Local state means the Terraform.tf state file is stored on your own machine, usually inside the project folder. This is okay for learning Terraform demos projects. Problem with local state. Local state has several problems. No share with team members. Easy to lose the files. No locking. Two people can run a blind at the same time. This is dangerous for real project. Remote state. Remote state means the state file is stored in a central location. Common example: AWS S3, Terraform Cloud, or Console. Why remote state is better? Remote state gives you shared access for the whole team, better security, backup, and versioning, state locking. This is why remote state is the standard in production. Terraform state file structure. Now let's look inside the state file. What is inside the state? The state file is JSON-based. It usually contains resource, instances, attribute, dependencies, output. Very important warning. State file often contain API address, resources ID, ARNs, sometimes password or secret. State files are sensitive data. Treat them like secret. Backend overview. Now let's talk about the backend. What is a backend? A backend is where Terraform store and manage its state. It also control, locking, state access, collaboration. S3 and DynamoDB. This is the most popular setup on AWS. How it works. S3 stores the state file. DynamoDB provides locking. Execute flow. When you run Terraform apply command, Terraform does this first. Locks the state in DynamoDB. Then read state from S3. Then update the infrastructure. Then update state in S3 and unlock the state. This prevents two people from applying at the same time. This setup is enterprise standard. Terraform Cloud. Terraform Cloud provides remote state, locking, state history, user permission, and web UI. Terraform Cloud is great when you have a large team. You work with multiple clouds. You want less backend management. State locking. Now let's focus on state locking. What is state locking? State locking is a machine that ensures only one person can modify state at a time. Why locking is critical? Imagine that two engineers run Terraform apply at the same time and on the same infrastructure without locking. This can cause corrupted state, incorrect resource, production outage. Locking protects Terraform's memory. Drift detection. Now let's talk about drift. What's a drift? Drift happens when real infrastructure different Terraform state. Common drift example. Someone delete an EC2 instance in AWS console, or someone change security group manually, or Terraform state is now out of sync. How Terraform detect drift? Terraform detect drift during run Terraform plan or Terraform refresh. Terraform compares what it remembers and what actually exists. Terraform refresh. What does refresh do? Terraform refresh read real infrastructure. That's the state file. Do not change infrastructure. It only updates Terraform's memory. Important note: in modern Terraform versions, refresh is usually built into Terraform plan and Terraform apply command, so you rarely need to run it manually. Terraform state commands. These commands are used for debugging and recovery. Think of them as emergency tool. These commands are very powerful. Use them carefully. Best practice. Please remember this rule. Never commit state files to Git. Never edit state files manually. Only modify state using Terraform CLI. This lesson is extremely important because today we answer a very practical question. How do you write Terraform code that can change, scale, and be reused? If your Terraform code only works for one environment, one region, one server type, then honestly, it is not real infrastructure across. Terraform becomes powerful when the same code can work for that staging and develop and production without rewriting everything. And to do that, we need three core concepts: variables, output, and reusability pattern. Let's start. Variable. Let me ask you a simple question. What happens if your Terraform code looks like this? This code works, but it has these problems. You cannot reuse it. You must copy paste for every environment. Changing one value means editing code. Very easy to make mistakes. This is hardcode infrastructure, and hardcode infrastructure does not scale. Solution: variable. Variables allow us to separate code from data. Same code, different values, different environment. That is flexibility. Variable type. Terraform variable has types. Type has Terraform valid input, catch error early, make code easier to understand. Primitive type. String, used for text value. Number, used for quantity. And boolean, used to enable or disable filter. Very useful for filter flash. Complete type. Now let's move to more powerful type. List. A list is an ordered collection. A map is a key value pair. And an object is a structural variable similar to JSON. Objects are perfect for complete infrastructure config. Default value. Sometimes we want sensible default. This means if user does nothing, default is used. If user override, Terraform uses the new value. Defaults have reduce required input, standardized environment, improve user experiences. But remember, defaults are optional. Do not overuse them. Variable validation. Now let's talk about safety. What if someone passed a wrong value? What happened? Terraform found earlier. Error message. No broken infrastructure. So validation is a guardrail. Very important in team. Sensitive variable. Some values must be protected. Example, password, token, API keys. Terraform will high value in plan, high value in apply. Important warning. Sensitive values are still stored in the state file. So you must combine this with remote state, encryption, access control. Sensitive does not mean invisible. It means handle with care. Output. Output are how Terraform return information. So after run Terraform apply, Terraform prints the published IP. In the real work, Reusability pattern. Now let's connect everything. Pattern 1. Parameterize module. Pattern 2. Environment-based variable. Pattern 3. Naming and task convention. Let's summarize. Terraform is powerful not because it creates resources, but because it creates reusable system. Remember that good Terraform code does not care about environment. Only data does. Variables is flexibility. Validation is safety. Sensitivity is security awareness. Output is integration. Reusability is scalability. In this lesson, we go one level deeper because Terraform is not only a tool to create infrastructure. Terraform is also a data processing language. Before Terraform creates anything, it first processes the input data to decide how many resources to create, what name they should have, what configuration each resource should use. So remember these sentences. Terraform is infrastructure and data processing. If you understand the lesson, Terraform will start to feel logical and predictable, not magical. Let's begin. String function. What are string functions? String functions are used to work with that. In real projects, strings are everywhere. Resource names, environment names, tasks, identifiers. Terraform provides function to combine string, change the case, replace character. First, combine string. This is extremely important for naming conventions. Avoiding name conflicts, multi-environment setup. Example 2, change the case. Why is this useful? Because some systems requires lowercase names. Some tasks must be uppercase. Consistency is very important in introduction. Example 3, replace character. Very useful when input data comes from humans. You want standardized resource names. Terraform does not guess what you want. You must explicitly transform data. String function help you do that safely. Collection function. What is the collection? A collection is a multiple value together. Terraform have 3 main types: list, map, set. Collection function help you inspect data, count items, check conditions. Example 1, length. If you have 3 subnets, Terraform knows the name before creating anything, often used with count, scaling logic. Example 2, keys and values. This helps Terraform look over tasks, transform task values, validate task structure. Example 3, contents. This returns true or false. Very useful for tracking environment type, enabling or disabling filter. Terraform treats collections as data, then use that data to control infrastructure creation. Number functions. Why numeric? Number control, scale, size, limits, cost. Terraform number functions help you compare numbers, enforces boundary, calculate values. Example 1, min and max. Meaning never create more than 2 and never create less than 1. This is cost control logic. Example 2, cell. Terraform can calculate values based on other values, useful for auto-scaling rules, dynamic sizing. Terraform calculator first, then create infrastructure. And type conversion. Why do we need type conversion? Terraform is very strict about data types. This is good, but sometimes inconvenient. For example, CI/CD sends everything as string. Module output return unexpected type. Terraform provide conversion functions. Common example: to string, to number, to list. These functions prevent high errors, make data compatible, improve reliability. Terraform does exactly what you say, not what you mean. So always make type explicit. Conditional expression. What is a conditional expression? Terraform supports inline if-else logic. Other environment, smaller instance. Same code, different behavior, no duplication. Why is this powerful? Because you avoid copy-paste. Logic stay in one place. Environment stay consistent. Terraform decide behavior before execution. It's a decision making, not scripting. For expression. What is for expression? They allow Terraform to loop over data, transform collection, create a new value. Common use case: subnet, security group rules, IAM permissions, naming convention. Terraform transform data when used the result to create infrastructure. Dynamic block. What is a dynamic block? Terraform does not allow loop directly inside resource blocks, so we use dynamic. A dynamic block generates next blocks based on input data. Example: Terraform first, read ingress rule. Net, loop over them. Net, generate ingress blocks. Where is this used? Security group, IAM policy, load balancer rule. This is advanced but essential Terraform. Terraform's process data, generate and create infrastructure. Let's connect everything. Terraform always follow this order. First, read input data. Net, process data. Net, make decision. Net, generate configuration and create the infrastructure. Remember these sentences. Terraform becomes truly powerful when you treat it as a data processing language for infrastructure. If you only write results, you are using 20% of Terraform. In this lesson, we are going to talk about one of the most important topics in Terraform, especially when you move from working alone to working in a team or an organization. The topic is, how do you scale Terraform for teams and organization? If you are still writing everything in one big main file, or copying or pasting Terraform code between projects, then this lesson is for you. By the end of this lesson, you will clearly understand what Terraform modules really are, how Terraform use module into work system, how to design modules the right way, and why modules are the foundation of scalable infrastructure. Let's start with the short answer. How do you scale Terraform for team and organization? You scale Terraform by standardizing infrastructure into reusable modules, versioning those modules, controlling input and output, and managing them centrally through a registry. Now let's go through this step by step, slowly and clearly. What is a Terraform module? Let's start from the basic. A Terraform module is simply a collection of TF5 groups together to do one specific job. That job could be creating a VPC, creating a EC2 instances, creating an application load balancer, or creating an RDS database. So instead of writing the same Terraform code again and again, you package it once into a module and then reuse it everywhere. Common real module include VPC module, EC2 module, RLB module, RDS module. Here is the simplest way to think about it. If a Terraform resource is like a bridge, then the Terraform module is a preview gun. You don't review the gun every time. You reuse it. That is the mindset. Root modules and child modules. The path is extremely important, especially for beginners. Root module is the directory where you run init, Terraform init, Terraform plan, and Terraform apply. It usually represents one environment or one deployment stack. And common example that staging and production. Each environment uses the same modules but with the different input. Child module. Child module is a module that is called by the root module. It contains reusable logic. It is not execute directly. Here's the root module say, hey Terraform, please use this VPC module. Very important rule. Let's remember, never run Terraform apply inside a child module. Always run Terraform command in the root module. Child module are review blocks, not executing point. Module input and output. Now let's talk about how module communicate. Input allow you to pass values into a module. For example, this means these modules do not decide the CIDR, the environment design. Why is this important? Because it makes your module flexible, reusable, free up hardcode values. You can use the same module for that, staging, production, just different input. Output allow a module to export value to the outside world. Example. This is how modules connect to each other. In your work, EC2 module need VPC ID. ARB module need a subnet IDS. Think of it like input is data go in and output is data come out. This is clean, predictable, and scalable. Standard for the structure. Now let's talk about the structure because structure is what allows him to scale. Why this work? Because it's a separate concern. Module is logic and standard. Environment is configuration and development. Benefit: no copy paste, easy to review, easy to onboard new engineer, easy to scale across team. This is how reorganization structure Terraform. This is child module and root module. Input and output. Module versioning. Let's talk about safety. Why version module? Without versioning, one tank can break on environment. You don't know what code is running where. With versioning, you control trend, you can run back, you can upgrade safely. You can upgrade safely. Public and private module. Public module available on the Terraform registry. For example, pub test you, well test, communicate, community supported, and cons very complete, hard to customize deeply. Private module written by your own team. Broad multi-business needs. Enforce a standard, easier governance. Every research organization ends up with private module. Public modules are great for learning. Private modules are for production. Terraform registry usage. What is a registry? A registry is a central place to store modules with the versions, with the documentation. Type of registry 3 times. First, public registry. Next, Terraform Cloud private registry. And next, there has a Git repository. Why registry master? They make module discoverable, version it, and consistency across team. Module design principle. This is standard level thinking. Principle 1. One responsibility. One module does one thing well. Principle 2. No hard coding. Everything comes from variable. Principle 3. Safer default. Safe, predictable behavior. Principle 4. Clear input and output. Export only what is needed, nothing more. And principle 5. Backward compatibility. Lab. Write the VPC module, last 2 EC2 module, and last 3 ALB module. Conclusion: Terraform only truly scale when modules are used correctly. So remember this, modules are the versioning is safety and registry enable sharing. Good design ensure survival. If you master Terraform modules, you are no longer just writing IAC. You are building infrastructure platform. In this lesson, we are going to talk about something that every real Terraform project must deal with, that is managing multiple environments. Because in the real work, we never have just one environment. We always have a development, staging, and production. And if you manage them incorrectly, you can very easily crash production, deploy to the wrong environment, leak secret, or destroy the wrong infrastructure. So in this lesson, I will explain this topic clearly, slowly, and practically, not just theory. How do you manage multi-environment? We manage multi-environment by clearly separating state, configuration, and secret, choosing the right environment strategy, and applying consistent naming and secret management. Now let's break this down step by step. Environment strategy. First, you need to understand one very important thing. Terraform does not force you to use only one environment strategy, but in real work usage, there are two main strategies that people use. Let's look at them one by one. For the base strategy, this idea is very simple. Each environment lives in its own folder. Its folder head, its own Terraform state, its own variable, and its own backend. Like this project have 3 environments: that, staging, and production. Each environment is put on each folder. You can think about it like this: that is the one Terraform project, staging is another Terraform project, and production is another Terraform project. They share modules, but they do not share state. Advantages. This approach is popular for a reason. Let's talk about the advantages first. It is very clear and very easy to understand. When you enter the prod folder, you know you are working with production. Second, it is very safe. A mistake in that will not affect production. Third, it works extremely well with CI/CD pipeline. Each environment can have its own pipeline, its own approval rule. And finally, this strategy is perfect for large team and enterprise. That is why most companies use it. Disadvantage, of course, nothing is perfect. The main disadvantage is some file duplication. For example, provide a configuration, backend configuration, but in practice, this is a small price to pay for safer clarity. Next, workspace-based strategy. Now let's talk about the second strategy. The work-based strategy uses one code base, multi Terraform workspace. You create workspace like this. Each workspace has its own Terraform state, but use the same code, and you usually combine this with dynamic naming. Terraform workspace. Now let's slow down and understand. What exactly is a workspace? Workspace is Terraform's way of managing multiple state files within the same configuration. That is, nothing more. By default, Terraform has one workspace called default, and you can add more that staging production. But remember that a workspace is not a real environment. It has only a different state file. This part is extremely important. Click and switch workspace. Pros and cons of workspace. Now let's see this very honest workspace look like at first, but you come with the characteristics. Pros. Let's start with the good part. Let's go fast and easy experimentation. Workspace are great for demo, learning, and proof of concept. Net cons. Now let's the dangerous part. Wrong workspace selected. Miss secret CI/CD complexity and not enterprise ready. Let me say this very clearly. One wrong Terraform apply in the wrong workspace can destroy production, and this does happen in real company. Terraform workspace are not recommended for production in enterprise environment. Use workspace only from a sandbox, future test, and demo, not for real environment. Naming convention. Now let's talk about something that looks small, but it's actually very important. That is naming. Why naming is critical? Good naming helps you avoid conflict, identify resources quickly, debug faster, track costs currently. Best naming leads to confusing, missed it, hire a cloud view. Standard naming pattern. Very common and say pattern is from the name along, you already know which project, which environment, and what resources. Naming with the workspace. If you use workspace, you often see this. This is okay when the workspace-based approach truly makes sense. Do not miss this blindly into enterprise projects. Environment. Now we are talking about security. Golden rule. Remember these two rules forever. Do not hardcode secret. Do not commit secrets to Git. If secrets are in Git, it is already too late. Correct approach. Terraform variable. You can use like this. Its environment has its out file. This file must be enhanced by Git, stored securely. Environment variable. Very common in pipeline. This is just secure, easy to rotate, CI/CD friendly. Secret manager. This is the best approach in production. Terraform reads the secret but does not manage it. This is very important. In this lesson, we are going to talk about the security in Terraform, and I want to be very clear for the beginning. Terraform itself is not dangerous. The way we use Terraform is what makes it dangerous. Most rework Terraform inside happen because of our permission in IAM, bad secret handling, and no safety guardrails. So in this lesson, we are not just listing features. We are learning how to think securely when Terraform is used by teams and enterprise. For answer, how do you secure Terraform? By locking down IAM permission, following the principle of least privilege, managing secret outside of Terraform, protecting sensitive data in state and output, and using guardrails to prevent destructive action. Now let's break this down step by step. IAM best practice. Terraform interacts with cloud via IAM. First, a very important concept. Terraform does not have its own permission. Terraform can only do what IAM allows it to do. So if Terraform deletes your production database, it is not Terraform fault. IAM allows it. Common IAM used with Terraform. In real project, Terraform usually runs as IAM user, IAM roles, and CI/CD role. Best practice. When using Terraform in teams, use IAM roles, not long line access keys. A separate role for Terraform apply, CI/CD pipeline, and human. Enable cloud shell, so you know who did what, when, and how. Best practice. Use administrator access for Terraform. People often say it is easy this way. Yes, it's easier, and it is also extremely dangerous. Terraform with admin access is basically root access to your entire cloud. Principle of least privilege. What does it mean? Principle of least privilege means grant only the minimal permission required, nothing more. Terraform specific thinking. Instead of using action values is on the specific value to action, and in made to set up wiggle event filter, scope by service, scope by region, scope by resources, ARN. Secret handling. This is where most Terraform disasters happen. Golden rule. Please remember this rule. Never hardcode secret. Never commit secret to Git. Never expose secret in output. If you practice rule, Terraform will eventually leak your secret. What counts as a secret? Secrets include database password, API keys, token, private keys, certificate. If losing it hurts your business, it's a secret. AWS Secret Manager. When should you use it? AWS Secret Manager is great when you need rotating secret, high security workflow, high security workload, complaint. How Terraform use Secret Manager. Like this. Important understanding. Terraform reads the secret. Terraform does not generate it. Terraform does not rotate it. Security note. Even when you Secret Manager, secret value will still appear in Terraform state. So you must increase state, restrict access to state files. Secret Manager have, but it does not magically show everything. AWS SSM parameter store. When to use SSM? SSM parameter store is great for config values, non-rotating secrets, simple secret, high security secret. Example. Sensitive output. The problem. Terraform outputs are print to CLI, locked inside CD, visible to anyone with access. That is dangerous for secret. Solution. We use sensitive equal to and result hidden in CLI, hidden in log. Important clarification. Sensitive equal to hides the output. It does not remove the secrets from state. State security is still critical. Prevent destroy. Why do we need this? Terraform destroy and production is gone. This happens more often than people want to admit. Where you prevent destroy, Terraform will refuse to destroy even if it is publicity told. Where should you use it? Always consider it for database at 3 buckets with data, critical EIM resource. Life cycle block. What is life cycle? Life cycle block control. How Terraform change to resources. Common life cycle. Common life cycle pattern. We should use the prevent destroy enough chance. Useful when tasks are managed elsewhere, right? Auto scale chain capacity and create before destroy. This have HG0 downtime replacement. Common anti pattern. Let's quickly list the mistakes that cause most incidents. Hardcode secret. Commit TF with secret. Admin secrets for Terraform. Exposing secrets via output. No protection on critical resources. Let's summarize how experienced team thinks. Terraform secret does not automate. IAM roles are better than accessory. This privilege is non-negotiable. They must be encouraged on and restricted. Like circle guardrail, and mandatory. Terraform is effectively infrastructure. In this lesson, we are going to talk about something very important for modern DevOps team, CI/CD pipeline for infrastructure. And the key question for today is, how do you auto infrastructure deployment? But not just automation. The real question is, how do you automate infrastructure deployment in a safe, controlled, and scalable way for team? Because automation without control is dangerous, and infrastructure mistakes are the expenses. In this lesson, we will use Terraform as our main tool, and I'll show you how real teams use Terraform inside CI/CD pipeline. Let's start for the basics. Terraform in CI/CD pipeline. What role does Terraform play in CI/CD? First, let's make one thing very clear. Terraform does not deploy application code. Terraform deploys infrastructure. That means Terraform is used for things like VPC and networking, ECS, EKS, EC2 load balancer, RDS database, S3 bucket, IAM role and permission. Terraform does not build your application, run tests, deploy backend front-end code in a CI/CD pipeline. Terraform job is to answer one simple question: does the geo infrastructure map what we define in code? If answer is no, Terraform can fit it. That is why Terraform is so powerful. Instead of clicking around in the AWS console, you describe infrastructure once in code, and Terraform reality master code. This is how teams avoid manual mistakes, keep infrastructure consistent, scale safety as the team grows. Terraform's position in pipeline. Now let's talk about where Terraform runs. A very simple pipeline looks like this. Terraform usually runs in a separate infrastructure state. As is not mixed with build state, test state, application development state. Why is this separate important? Because infrastructure changes are risky, sometimes destructive, much harder to run back. In real company, application codes may be destroyed many times per day. Infrastructure changes are fewer and more controlled. Teams belong to the infrastructure layer, not the application layer. Plan and apply workflow. This is the heart of Terraform in CI/CD. If you understand this part, you understand how to use Terraform safely. Terraform plan. What will change? When you run Terraform plan, Terraform does three things. First, read your Terraform code, design state. Net, read AWS current state. Net, compare them. Then Terraform show you what will be created, what will be updated, and what will be deleted. Important thing to remember. Terraform plan made no real change. It is safe to run automatically. It is perfect for CI pipeline. The output of plan is a change contract. It's like saying, if you approve this, this is exactly what will happen. This is why plan should always run automatically. Terraform apply makes it real. Now let's talk about the Terraform apply. Apply is where Terraform creates resources, updates resources, deletes resources. This is real action. If Terraform say this RDS database will be destroyed and you run apply, your database is gone. That is why Terraform apply is dangerous without control. Automation is good, but uncontrolled automation is not. Standard workflow. So what is the correct workflow? Here is the industry standard. In a simple work, First, a developer open a pull request. Then CI automatically run Terraform plan. Then the team review the plan output. Next, someone approves, and next, only then Terraform apply the change. Terraform should never surprise you. If something breaks, you should be able to say, yes, we review and approve it. Approval process. Why is the approval processory? Because Terraform can delete database, destroy VPC, recreate load balancer. One wrong commit can take product down. Never allow automatic to apply in product. Never. Common approval approaches. First, manual approach in CI. This pipeline points and waits for a human decision. Next, pull request based approval. Only pull request with approvals can be merged. That is simple and very effective. Next, separate apply pipeline. Very common in legacy team. Plan run automatically. Apply a separate job. Must be manual feature. Maximum safety. Remote backend for CI. Now let's talk about the Terraform state. Why not your local backend? Because CI runner as stateless, temporary, destroy after each run. That means local state is lost. No change sharing, no locking. This is bread Terraform. Remote backends are mandatory in CI. Benefit: remote backend give you share state across the team, state locking, safe parallel execution, reliable CI/CD. If you use Terraform in CI without a remote backend, you are doing it wrong. Terraform Cloud. What is Terraform Cloud? Terraform Cloud is the official SaaS platform from HashiCorp. It provides remote state logging, secure variable, policy as code, UI for plans and apply. When should you use it? Terraform course is not required, but it makes life much easier for team. Hit up mindset. Now let's talk about the mindset. What is mindset? What is GitHub? GitHub means Git is the single source of truth. With Terraform, this means no manual infrastructure change, no just this one-time fix, no clicking in production. Every change must go through Git, be review, be version. GitHub flow with Terraform. The AWS console is for viewing, not modifying. Automatic detection. What is dip? Dip happens when real infrastructure is different Terraform codes. For example, someone edits a security group manually. Someone changes an instance size, and Terraform codes and utility are different. The ways to detect dip: first, schedule Terraform plan. Run daily or weekly. If change are detected, alert the team. Next, Terraform Cloud Grip detection, build filter. Next, policy monitoring, cloud trail alert. Complaint chat, dip is normal, if not dip is dangerous. Lab. Create a lab architecture like this. Create a folder and have a list at least 3 files and create another folder to include the GitHub action workflow. How do you avoid breaking production? A practical way. How do you make sure Terraform changes do not blow up a running system? Let me start with a scary but very real situation. Imagine this. You write a small Terraform change, just a tiny update. You run Terraform apply, and suddenly a database is deleted, a load balancer is recreated, and production goes down. No bugs in your app, no server crash. Only Terraform doing exactly what you told it to do. So the real question is not the Terraform work. The real question is how do we control Terraform so it doesn't destroy production? Terraform is not application code, so no unit test, no integration test, no mock servers. Instead, Terraform quality is controlled by layer of protection, validation, formatting, planning, policy, security scanning, human review. Tens of this lesson as building a safety system around Terraform. Terraform validate first line of defense. Purpose. Terraform validate just is this Terraform code valid? It answer. Is the syntax correct? Does Terraform understand this configuration? What's the Terraform validate check? It just thin line. ACL syntax is valid. Variables are declared. Resources references as data type map, for example, string and name, list and map, which is not checked. This is very important. Terraform validates does not check if AWS resources are actually asset, if IAM permissions are correct, if security rules are safe, if costs are reasonable. It's only just struct, not reality. An example, we run Terraform validate simple, fast, knowledge. When should we use it? Before committing code. As the first step in CLI every single time. If a Terraform validate fault, nothing else should run. Terraform add format clean code and is a safer code. Purpose. Terraform format make your code readable, consistent, review friendly. Why formatting matter is in Terraform? Terraform automatically format indentation, brace, attribute order. Why does this matter? Because reviewer focus on logic, not spacing. Pull request are clean. Git conflicts are reduced. Example, we run the Terraform fmt or Terraform recurses. Best practice, always run before pushing. CI should fail if formatting is wrong. Never review unformatted Terraform code. Format is not optional. It's hygiene. Terraform plan, the most important step. Purpose. Terraform plan answer one critical question. What exactly will change? This is where production safety lies or die. What does the plan show? The plan tells you which resources will be created, which will be updated, which will be destroyed. You will see the simple like the You receive the simple like this, right? Why the instruction master Terraform is very powerful, and power means danger. A plan may say destroy RDS, recreate ARB, replay EC2 instances. If you miss this, production is gone. Why you out? This is critical. You out ensure the plan is reviewed. The applied change match the review plan. It prevents one plan but different apply. Production reality. In real time, engineer generated the plan. Let rename the plan. Let review the plan. Apply happen only after approval. Never apply directly in production. Policy at code. Machine stop human. Cause idea. Human mistake. So let's machine block dangerous change automatically. This is policy at code. Sentinel. What is Sentinel? Sentinel is a HashiCorp's policy engine. You with Terraform Cloud Enterprise. It enforces rules like allows the instance type, require tasks, no public resources. This is the example. Right? If violate Terraform run is blocked, when to use Sentinel, Terraform Cloud User, Enterprise Environment, strict governance requirement. OPA, Content Open Source Alternatives. What is OPA? OPA stands for Open Policy Agent, Open Source, Vendor Neutral. Content use OPA to test Terraform plans. Workflow. Terraform plan, then convert to JSON, then can test. Why team love OPA? Because it's open source, CI/CD friendly, works anywhere, no vendor lock. Static analysis, CAT, security is used early. Static analysis, CAT security is used early. Goal director, security risk, complaint violation, bad cloud practice, before apply and before operation. TFSAT, security fox. What is TFSAT? Terraform security scanner, focus on cloud security best practice. Example, TFSAT pawn. TFSAT detect public S3 bucket, security group open to the world, unencrypt database, and over permissive IAM policy. Perfect for DevOps and security team. Checkoff. Complaint focus. What is Checkoff? Statistical analysis tool. Support Terraform, Kubernetes, and CloudFormation. Map to standard line. CIS, SOC, PCS, DSS, example, right? Checkoff D. When to use Checkoff? Complaint requirement, audit, enterprise environment. Code review, humans still master. Automation is powerful, but humans are the final defense. Terraform code review checklist. First, infrastructure impact, any resource destruction, any force recreation, and production impact. Next, security. IAM tune to permissions, public asset, encryption enable. Net cost, instance size reasonable, expensive service, auto scaling enable. Next, Terraform quality. Module used correctly, variable clear, naming consistencies. And then stay and workflow. Remote backend, stay logging, apply from approved plan. Summary. Terraform doesn't protect production by magic. It's survival because of process. Which Terraform engine doesn't trust they trust system, trust and discipline. If you master this lesson, you are no longer just writing Terraform, you are protecting production. How do standard engine write Terraform? Let me say this very clearly. Standard level Terraform is not about writing more resources, nor in more AWS services using fancy syntax. Standard Terraform is about design. It must scale to larger system, be readable for years, support change without downtime, be safer for production. At junior level, Terraform is it work. At standard level, Terraform becomes can the system survival, growth, chance, and mistake. Standard engineers do not just write Terraform. They design infrastructure system with code. Large scale architecture. The problem at scale, Terraform works great until it doesn't. Amazing. Hundreds or thousands of resources, multi-environment, that staging production. Many teams dragging code at the same time. Without structure, Terraform becomes a huge mess. How standard engine thinks? Standard engine always start with structure. Split by layer. Instead of one giant Terraform project split by responsibility. Why this work? Each layer has its own state, clear ownership, clear dependency flow. Split by environment. Never do it. One Terraform stay with cloud or for that and production instead. Each environment has its own folder or workspace. Each environment has its own state. Golden rule. One Terraform state equals one clear responsibility. Module composition. Goal. Standard engineer build Terraform like Lego blocks. Small pieces, clear purpose, easy to connect. Junior module and senior modules. Junior module try to solve everything. Too many variables. Hard to understand. Senior modules do one thing well. Opinionated, easy to read. You can understand this. Junior module and senior module. Junior module try to solve everything. Too many variables. Hard to understand. Senior module do one thing well. Opinionated, easier to read. You can understand it without opening the module. That is the senior level design. Important rule: a Terraform module is not reviewable for every company, reviewable inside your organization. The right and readability. The class debate. Dry mean don't repeat yourself. So good, but that is tough. Senior decision. Readability is more important than esteem dry. Overly dry code. This is hard to debug, hard to explain, hard to review. Net, clear and explicit code. Longer, yes. Clear, absolutely. Terraform is written once, read hundreds of times. Monorepo and multi-repo. There is no best choice, only the right choice for your organization. Monorepo on Terraform is one repository. Best from small to medium team and platform teams. Multi-repo is team service, has its own repo. Best for larger companies and many product teams. Handling breaking chains. What is a breaking chains? Things like renaming a result, changing for each keys, restricting modules. Terraform sees it as destroy and recreate. That can mean downtime. Send tenet line circle. Prevent a silent destruction. Terraform is refused to destroy the result. Move. Tell Terraform that resource move. This avoids destruction during refactors. And finally, multi-step run loud. Never do legal refactor in one PR. Importing existing resources. The situation: you join a company, infrastructure already exists, no Terraform stay, but you want Terraform to manage it. Correct flow. First, write Terraform code to match the real result. Next, import the result. And finally, run Terraform plan command. The plan must show no change. Command mistake: import first, write code later, mismatch attributes, surprise destruction. Refactoring without downtime. Goal: change infrastructure without user noticing. Center tenet. First, blue or green deployment. Net, create before destroy. And finally, state separation. Working with legacy infrastructure. Reality check. Legacy system are old, inconsistent, poorly documented, and usually very important to the business. Standard abroad. Don't destroy everything. Important gradually. Grab legacy resources with module. Net standardize slowly. And finally, at God draw. Goal is not a perfection, it's control. Finally, junior engineers, will this work? And senior engineers, will this still work in 3 years? If you think this way, you are already writing senior level Terraform. In this lesson, we are going to talk about something very important and also very painful for many teams. Why the Terraform often fails? Why there is few like Terraform breaks more and more as system grows? Let me be very honest with you. Terraform itself is not difficult, but Terraform is very easy to misuse. Most Terraform disasters are not bugs. They come from poor design, misunderstanding how Terraform works, careless state management. This lesson will help you avoid those mistakes and debug Terraform like a senior engineer. Here is the key mindset: Terraform does not fail because it's wet. Terraform fails because we use it the wrong way. If you understand this lesson, you will break production less, budget faster, sleep better at night. Common mistakes. Let's start with the most common NG pattern. These are mistakes I see again and again in real company. First, one stay for everything. This is the number one mistake. We usually put VPC, ECS, RDS, S3, IAM, and everything into one single Terraform state. Why this is dangerous? Terraform plans become very slow. Many people cannot work in parallel. One small mistake can destroy everything. One bad apply entire system effect. Correct approach. Split your Terraform by responsibility. For example, network, computer data, security, and also split by that stating product. Golden rule. One Terraform state should have one clear responsibility. Net misuse count for environment. You may have seen code like this. This looks clear, but it is very dangerous. Why these bad things? Count you analysis when condition change, analysis change. Terraform tensor resources move. Terraform destroy and create them. Very hard to purchase, very easy to break production. Correct approach. Do not use count for environment. Use separate folders or separate workspaces. One environment is one state. And net, not pinning provider version. This look harmless. AS is extremely dangerous. Why? Provider change, API change, and default behavior change. Same code today, different plan tomorrow. That is how routine change turn into destruction. Correct approach. Always pin provider version. Same like require providers. Same code and same provider is a predictable behavior. Circular dependencies. This problem. Terraform must know what to create first, but sometimes we create circle. Example, result A depends on B, and result B depends on A. Terraforms get confused. In the real work, a security group reference an ENI, then ENI references the security group. Terraform cannot decide which one comes first, and how to avoid. Decide clearly. Network first, then compute, then data. You depend on only when absolutely necessary. Important rule: if unit many depend on blocks, you attitude is probably wrong. State corruption. State is the side of Terraform. Terraform state content real resources ID mapping between code and infrastructure. If state is broken, Terraform is blind. Common cause of state corruption. Editing TF state manually. Two people run apply at the same time using local state in a team. Backend without blocking. Simpleton. You may see Terraform want to destroy running resources. Terraform blend does not match reality. Very stringent prevention. Always use a remote backend. Enable state locking. Never edit state manually. Golden rule. Protect the Terraform state as on cost. Provider related issue. Why provider cause many problems? Provider as the bridge between Terraform and the cloud. Cloud API change, provider change, first happen. Common provider issue, wrong provider version. Is by AWS credential, wrong region, missing IAM permission. Critical step. Run init and provider command. Then check AWS credential, environment variable, IAM permission, region setting. Most provider person as configuration problem, not Terraform bot. Debugging technique. Let's talk about how senior engineers debug Terraform. First, read Terraform plan and carefully. Do not rush. Pay attention to create, update, destroy, and especially destroy and replay. If you see destroy in production, stop and investigate. Next, target apply. This is useful during debugging, during emergency fix, but never use in CI, never use as a normal workflow. This can break state consistencies. Next, state inspection command, very powerful tool. Use them when infrastructure exists. States do not match reality. You import resources. Logging and troubleshooting. Enable Terraform logging. When things get really well, run this command. Log levels, trees, vertex, info, 1, alert. You chase only when necessary. Log can be huge. Standard troubleshooting workflow. When something goes wrong, let step-by-step tracking. First, Terraform variable, validate. Next, Terraform plan. Next, check provider versions. Next, check credentials and permission. Next, check state, and next, check analog if needed. And never jump straight to apply. Summary. Terraform failures usually comes from misuse, not Terraform itself. In this lesson, we are not just learning how to write Terraform. We are learning something much more important. How professionals use Terraform in real companies. How they use it safely, cleanly, and in a way that grows their career. So let's start with today's key questions. How do professionals use Terraform? Or more clearly, how do professionals use Terraform is a way that is secure, scalable, and supportive of long-term career growth? The answer is not just about syntax, it's about code quality, team collaboration, responsibility, and professional mindset. Let's break it down step by step. Clean Terraform code. Objective. The goal of clean Terraform code is very simple. Write code that is readable, maintainable, scalable, and loud. Remember this, you will read Terraform code many more times than you write it, so clean code really matter. Better practice. Clear directory structure. Net. Meaningful resources and variable names. Next, no hard coding values. Next, keep files small and single purpose. Documentation standard. Why documentation master? Many people think Terraform code is for machines. That is wrong. Terraform code is also for human. Future you, your teammate, new hire, they all need to understand it. Practical documentation standard. README for each module. Commands for complete logic. And Terraform doc. Team collaboration. Terraform is always a team activity. In real company, Terraform is never you alone. Mistake effect, production system, customers, business money. So collaboration rules are strict. Professional collaboration practice. Remote backend and style logging. Net Git workflow. Net CI/CD for Terraform. Co-ownership. Who is responsible when Terraform causes downtime? This is a serious question, and professionals have a clear answer. Ownership principle. Each module has an owner. Mandatory review and change logs and versioning. Talk about interviews. Common interview question. Concept question. You should confidently explain Terraform and CloudFormation. Count and for each. Local state and remote state. When to use modules. Interview task thinking, not memorization. Debate and real-world questions. Example, why the Terraform plans differ from apply? How do you handle infrastructure drift? Is the important resources risk? Real answer comes from real experiences. System design question. Example, design a Terraform structure for multi-account AWS. A strong answer show environment separation, module reuse, security awareness, team workflows. This is the senior level thinking. Terraform learning roadmap. Look at a clear roadmap. Level 1 foundation. Level 2 real world usage, level 3 production, and level 4 advanced. Career path, which Terraform open many career doors. DevOps engineer, cloud engineer, platform engineer. Remember, Terraform is not just about writing infrastructure code. It represents team collaboration, design thinking, ownership, and responsibilities. This is the more important lesson is the whole Terraform series, because here we stop learning concept only and we start building one thing real. How do you apply everything you have learned, or more clearly? How do you use Terraform to build a complete real-world AWS infrastructure that is real for production? That is exactly what this capstone is about. Build a complete AWS infrastructure. The goal of this capstone is not just to make Terraform run. The real goal is to build infrastructure that can scale, can be maintained by a team, and can be used in real companies. This is how professionals think. Code review and refactoring. Ask yourself, are modules reviewable? Are variable names clear? Is anything hard code? Are outputs really neat? Is there a risk of deleting important resource? This mindset separates junior from senior. Production ready mindset. Before finish, ask yourself this question. What if an apply fails? Can I run bad? Who owns this resource? How do I delete infrastructure drift? These are real production questions. After finish this lesson, you will be able to say, I can build a complete AWS infrastructure with Terraform. I understand why the architecture is designed this way. I can use this project for job interview, teaching, portfolio building.